Hi, we are team number 2, and during this video we are going to present you what is the best option for a family of 4 people in Querétaro, if it is better to buy a traditional car or a hybrid car. During this video we are going to present you a theoretically and numerically analysis about what is the best option for this hypothetical family. First, a traditional car is a car that it has a motor inside, and it works with gasoline that supplies energy to a shaft and also to the wheels so it can move. And a hybrid car, we know that it's a combination of 2 parts, a combustion motor and an electric part, but we have 3 differences. Hybrid in theory car is where the electric part moves the wheels and the combustion part supplies energy to the batteries. Hybrid parallel is where both of them supplies work to the wheels, but it's not very efficient and it's complicated to use. And hybrid combined cars is where both of them supply energy to the wheels, and is the best option, and is the most used hybrid type car that exists in the market.
Some of the pros about gasoline cars is that they are cheaper. It's easier to get the fuel, you can find it almost everywhere, and the maintenance is way easier to find it and to have it. Some of the cons about it is that you have more impact on the environment, the price of the gas will keep going up, and they have less lifetime than a hybrid car.
Some pros of hybrid cars are they are environmentally friendly and they have lower emissions than their conventional gasoline cars. There are more efficiency when you drive in the city, and they have a lot of durability, almost 200,000 miles. But some cons of hybrid cars are they are not efficiency when you drive in highway at high speed. They cost a few thousand more than the normal cars, and you have to take a lot of time to recoup your environment.
Now first, for the thermodynamic equations, we are going to start with the first law. In here we have that it's an adiabatic process, so we have that Q in and Q out is equal to 0. Also the workout, we are going to assume that is equal to 0, and we are only going to use the kinetic energy, the internal and potential, we are going to neglect it. And now we have in here the information that we obtained from our investigation, and this data we are going to compute in order to obtain the efficiency. And here we're comparing the data and the periods. So with the first law, we obtain the working and the work out for each one.
So we use the acceleration. We use these 2 values of velocities because we were considering that we're not going to take the velocity at 0, starting at 0, because that wouldn't be a steady rate at which the car is moving. So we started with 20 kilometers of initial distance and final distance of 70. These are our assumptions. After that, we get the acceleration with the formula of distance. We get the distance that the car made in this time and these velocities and accelerations. And then after that, we want to get the liters per 100 kilometers. This value was taken from the kilometers per liter of the cars, get that in amperes. After that, we multiply this value that we obtained by the distance that the car had to make, and we obtain the liters, this amount of liters. Those amount of liters, we multiplied by the calorific value of premium. This was a data that we researched and we found. And after that, we obtained this in kilojoules. These kilojoules, we next use it finally in here, the workout, the working that we did get at the other part. And the working divided by the final value that we obtained here gave us our final efficiency for the Jetta and the Prius.
So we made an economic analysis of these 2 cars, Jetta and the Prius. So we can see here the initial price of the Jetta and the initial price of the Prius. We assume that we're using premium gas, that today is 18.19 pesos. We're assuming that the car is using 100 kilometers per day. So with the kilometers per liter of the Jetta, we divide it over 100, so we get the liters per 100 kilometers. We get the pesos spent in a day. We multiply it by 365, and we get the money in a year. Then we do the same thing with the prices, and we get this money. So we get the difference in initial prices and the difference in gas in a year. So we get to the conclusion that in 5.51 years, the traditional car will be more expensive.
As a conclusion, we can say that after the analysis and results that were presented by my teammates, with these two results of the efficiency of the cars, the Jetta was 7.09% and Prius 12.7%. We can say that the Prius is a better car because it helps with the environment and the result of the efficiency is better. And also because after 5.5 years, the Jetta